Okay, hello everyone. Yesterday we looked at operations with complex numbers. Today we'll look at solving quadratics with complex zeros. But before we get that, some introductory material. So to recall, yesterday we learned that I is equal to the square root of -1. Okay, so keep that in mind. That's going to be very important for today's lesson. So let's say here I wanted to simplify the square root of -18. I can write that as a product of factors. Square root of -18 I could write as the square root of 9 times the square root of 2. 9 times 2 is 18 times the square root of -1. Again, we have to find the largest perfect square number of 18. Now, the square root of 9 is 3, so this will be 3. But then the square root of a -1 is I. Okay, so and we always put the I in front of the radical, and then we have left over root 2. Okay, so let's just do what I just did. So we took the square root of 9, and we got 3. And then we said that the square root of -1 was I, and that left us with the square root of 2. Simplified. Let's look at another one. So here we have 7 times the square root of 4 times the square root of 2, because 4 times 2 is 8, times the square root of -1. Now again, the square root of 4 is 2, so we'll have 7 times 2, and then the square root of a -1 is I, so we'll have times I, and then what's left over is root 2. Okay, so again, we took the square root of 4, we got 2, and the square root of -1 gave us I, and so 7 times 2 is 14, so we have 14I root 2. That's the final answer. And then the last one, so we have 2, so we can simplify this as 2 times the square root of 9, because 9 is the largest perfect square number, or factor of 9, times the square root of -1. And then again, the square root of 9 is 3, so we'll have 2 times 3, but the square root of -1 is I, and so this will equal 6I. Aye. Okay, so with that, we'll be using those operations to solve quadratic equations with complex zeros. But so that's the background knowledge. And again, let's just look at some more examples here. So here they give us express the number in terms of I. So 5 times the square root of -121. So we break that up into the 5 times the square root of 121 times the square root of -1. I like to write it like 5 times the square root of 121 times the square root of -1. But they wrote it underneath the radical. You remember the property of radicals, the square root of AB is equal to the square root of A times the square root of B. So, oh, well, okay, but so there they use that property there. I guess I didn't see that. All right, and then a square root of 121 is 11, and 5 times 11 is 55, and of course, the square root of -1 is I. So 55I. And again, so here we had a negative, the square root of a -96. And then we break 96 up into 16 and 6, because 16 times 6 is 96. And then we have the square root of -1. The square root of 16 is 4. So we have the 4 there. We have square root of 6 left over, times the square root of -1. But then the square root of -1 is I, and we always write I in front of the radical. Always write I in front of the radical, not behind it. Okay. Just a couple more examples. Here we have the square root of -12, which becomes the square root of 4 times the square root of 3 times the square root of -1. The square root of 4 is 2. We have 2 root 3 times the square root of -1. And then the square root of -1 is I. Bring the I in front of the radical. 2I root 3. Okay. now we'll be solving equations. So let's say here we're trying to solve the equation x squared is equal to negative 144. And I think I was telling you yesterday, you will never be able to use decimals to figure these out, right? Because, well, they'll involve imaginary roots. So, I mean, if you take a look at the function x squared looks like this here, right? But then we're saying, hey, where does that function cross the line y is equal to negative 144? Well, that would be way down here somewhere. So this would be y is equal to negative 144. So what we really have, we have a system of equations. So we have y is equal to x squared, which is that red, that parabola, and then we have y is equal to negative 144. And they will never cross. Okay. So we'll have imaginary roots. So here we take the square root of both sides, or square root of both sides, and we get x is equal to plus or minus the square root of 144, negative 144, but the square root of negative 144. And well, that's equal to, you break that up, that's the square root of 144 times the square root of negative 1, plus or minus, and then that's just plus or minus 12i. Let's look at the next one. So we want to find and solve the equation, find a 0. So we subtract 90, divide by 5, we get x squared is equal to negative 18. Take the square root of both sides, and then we get x is equal to plus or minus the square root of negative 18, which is plus or minus the square root of 9 times the square root of 2 times the square root of negative 1. And the square root of 9 is 3, so plus or minus 3. And then we have the square root of negative 1 is I, and then root 2, plus or minus 3i root 2. Oops. The next one, solve the equation. X squared plus 48 is equal to 0. X squared is equal to negative 48. Subtract 48 from both sides. We have plus or minus the square root of negative 48, which is, let's see here, 16 and 3, right? 16 times 3 gives you 48, so plus or minus the square root of 16 times the square root of 3 times the square root of minus 1. But that kind of scribbled there. The board moved on me. All right, and the square root of 16 is 4, so plus or minus 4. And the square root of negative 1 is I, so 4i root 3, plus or minus. Okay, so why learn all of that? Because now we use it to find the zeros, solve equations. So let's say here we want to find the zeros for f of x is equal to that. We'll set that equal to 0. 0 equals x plus 2 squared, plus 27. We'll subtract 27 from both sides, so negative 27 equals x plus 2 squared. We'll take the square root of both sides, and then we'll get plus or minus root negative 27 equals x plus 2. And then we'll break this up into plus or minus, what's that, 9 times the square root of 9 times the square root of 3 times the square root of negative 1 equals plus x plus 2. And then this will be plus or minus 3i root 3 equals x plus 2. And then finally we'll get x, so negative 2 plus or minus 3i root 3 equals x after subtracting 2. All right. Final answer. And again, you'll never be able to get those roots on decimals because they're imaginary roots. They have that I. Let's look at the next one. So here, again, we want to find a 0, so we'll set this equal to 0 and solve. Subtract 72, we have and then we'll take the square root of both sides. We'll have to divide by 3 first. We'll divide by 3, oh gee, what is it? 72 divided by 3. Oh, even I forget. 72 divided by 3, so that's 2, that's 6, that's 20, that's 24. Yeah, 24. Long division. I bet you forgot that. Or actually short division, because it's not very long. All right, so that's 24. All right, so we'll get a negative 24 then. So this would be negative 24 equals x minus 4 squared. Take the square root of both sides, and then we'll get plus or minus the square root of negative 24 equals x minus 4. And then we'll have plus or minus the square root of 4 times the square root of 6 times the square root of negative 1 equals x minus 4. And this will be plus or minus 2I root 6 equals x minus 4. And then finally we'll add 4 to both sides, and the final answer will be 4 plus or minus 2I root 6 equals x. Like I told you, when we get to chapter 6, guys, it's not, most of the quadratic equations we solve will involve imaginary answers, okay? Being able to use Desmos just does not come up very much from here on in. You have to be able to solve quadratic equations. All right, the next one, again, we'll set this equal to 0. So I'll have 0 equals x squared minus 6x plus 24. Let me write this over here. I'm running out of room. Okay, when I go down, subtract 24, so negative 24 equals x squared minus 6x. Okay, but we don't have square roots, right? I mean, with the other ones, they were in vertex form. See that? Vertex form. The vertex is 472. The vertex form, the vertex is negative 227. And then we have another yep. But this is not in vertex form. So what do? We complete the square, right? So again, remember, you complete the square and x squared minus 6 on the quadratic and linear term. So I'm going to complete the square, so I'll draw my square. So we take that x, and we say, hey, x squared is x times x, and then we take that negative 6, and we divide that by 2, and that would be negative 3. And so we have our x squared minus 3x minus 3x. Well, that's my x squared minus 6x, but then we're going to add 9. Okay, so we're going to add 9. So we'll have 9 minus 24 equals x squared minus 6x plus 9. Oops, I want it red. It's red on the left, make it red on the right. Right, so but this here, this is just x minus 3 squared, right? So that's x minus 3 squared. And then, of course, 9 minus negative 24. Ooh, what is that? 15, right? Negative 15? Oh, yeah, negative 15. So this would be negative 15 equals that. And then we take the square root of both sides. And then this will be plus or minus the square root of negative 15 equals x plus 3. But then this will be plus or minus the square root of negative 15, 15 times the square root of negative 1, which is just going to equal plus or minus I root 15, because we can't simplify root to 15 anymore. And then we bring down our x plus 3. And then we subtract 3, and we get negative 3 plus or minus I root 15 equals x. Solved. And then one more of these. And then you guys will get some homework. Now, because you can't check this stuff on Desmos, I will provide you with an answer key. Okay, just don't give me the answers. If I see you just give me the answers, I have to give you no credit. Try and get the answers that are on the answer key. Show your work. All right, and then the last one. So 0 equals x squared minus 8x plus 48. Pause the video and see if you can do that. See what answer you get. So I have negative 48 equals x squared minus 8x. I'm going to complete the square on that. No, come on board, don't move on me. Okay, I'll complete the square. So I'll have my x, and that's my x squared. And I'll take negative 8 and divide that by 2, and that's negative 4. So negative 4, negative 4. Remember, we're just working with a quadratic and linear term, and we should have all of that be the same when we add it up. And so we have minus 4x and minus 4x, and woohoo, it is the same, x squared minus 8x, and that's what we want. And then we complete the square, negative 4 times negative 4 will give us 16. And so that's what we'll add to both sides. So we'll have 16, and then we'll have minus 48 equals x squared minus 8x. We added 16, so plus 16. But that's just x minus 4 squared. And let's see here, so that would be negative 32, right? 16 minus 48 is negative 32. There we go. Right, yep. And then we take the square root of both sides. And then you get plus or minus the square root of negative 32 equals x minus 4. So we have to deal with that pesky negative underneath the radical and simplify that puppy. So we have plus or minus the square root of 16 times the square root of 2 times the square root of negative 1. And that will be plus or minus 4i root 2. Root 16 is 4 and square root of negative 1 is I. And that equals x minus 4. And then finally we add 4. 4 plus or minus 4i root 2 equals x. And it is solved. Again, all of these involved imaginary roots. See, they all had that I. They all had I. Popeye the Sailor Man. Okay, so there you go. Alright, so review the video as you're doing your homework. This should help. Okay, follow the bouncing ball.